After completion of this section, the student shall be able to analyze and describe the information given on the pressure volume diagram, PV diagram. The vertical values are given in bar, and the horizontal is the crank angle expressed in degrees, and given in respective values as shown in the next sequence. The position of the piston when moving upwards towards top dead center are shown as negative crank angle values, minus. The position of the piston when moving downward towards bottom dead center are shown as positive crank angle values, plus. This diagram shows a normal combustion process. Later on in this chapter, this diagram will be shown as a dotted line when failures in the combustion process are illustrated. This figure shows a diagram from a two-stroke diesel engine in which fuel ignition is taking place too early. In this diagram, the normal diagram is shown by the dotted line. You will see that when compared with the normal diagram, the combustion pressure is too high and the expansion line is lower than in the normal case. In the diagram, it can be seen that combustion is beginning before the piston has reached its top dead center position. Also, the exhaust gas temperature shows lower values than normal. As the combustion process is started a little bit higher up in the cylinder than in a normal situation, this will lead to an increase in heat radiation towards the upper part of the cylinder, resulting in a higher temperature in the cylinder cover and components mounted in this unit. A result of this is that the wall temperature in the cylinder liner will be lowered. As the power for the actual cylinder increases, the automatic regulation of the engine will carry out a corresponding reduction in fuel rack position. The total power is to be the same in both situations, early and normal, as the RPM set point has not been altered. This leads to a reduction in fuel oil consumption. The maximum cylinder pressure leads to increased mechanical loads on bearings, etc. Remedies in correcting an early injection. Control the camshaft position relative to the crankshaft. Adjust the fuel pump to correct lead. Manufacturer's instructions. Adjust the VIT. This diagram is from the same engine, but in this case the ignition is taking place too late. When compared with the normal diagram, it can be seen that the combustion pressure is lower and that the expansion line is higher than normal. From the diagram, it can be seen that the piston has passed the top dead center before the combustion starts. The output from the specific cylinder falls, and, generally, the exhaust temperature is higher than normal. As the combustion process is started a little bit lower in the cylinder than in the normal situation, this will lead to a reduction in heat radiation towards the upper part of cylinder, resulting in a lower temperature in the cylinder cover and components mounted in this unit. The wall temperature in the cylinder liner will, however, be higher than in normal condition. As the effect for the actual cylinder is reduced, the automatic regulation will carry out a corresponding adjustment leading to an increase in fuel rack position. The total power is to be the same in both situations, late and normal, as the RPM set point has not been altered. This results in an increase in the fuel oil consumption and thus in the economical running costs. A too late combustion process leads also to increased exhaust temperatures and aggravation of the combustion cycle, leading to an increase in soot formation. The following actions can be taken to correct a late injection. Control the camshaft position relative to the crankshaft. Note, MAN B&W engines have chain drive, while Sulzer engines have gear drive. The following actions can be taken to correct a late injection. The fuel valves must be controlled regarding correct nozzle holes injection pressure. Adjusted to correct value, manufacturer's advice. Control atomization, and if any leakage is present, this must be rectified. The following actions can be taken to correct a late injection. If poor pressure characteristics of fuel pumps are present, a check aiming to identify where in the fuel pump must be carried out. Adjust the fuel pump to correct lead. Manufacturer's instructions. Adjust the VIT. This illustration shows a diagram from an engine in which the compression, combustion and the expansion lines are all too low. The exhaust temperature is too high and the engine output is too low. The reason for this can be as follows. Leakages at the piston rings, wear of cylinder liners and rings, leaking exhaust valve, scavenging air blocked, the suction filter of the air cooler is dirty or the engine room blowers are not providing sufficient air, that is, low turbocharger pressure, turbocharger failure, blockages in the exhaust system. Checking whether the piston rings and exhaust valves are tight can be done by referring to a compression diagram. They are sufficiently tight if the ratio between the absolute compression pressure and the absolute scavenging air pressure is the same as it was during test trial.